I'd like to take a few minutes here and talk to you about Solid Edge with Synchronous Technology and what makes it different than other CAD systems that are out there today. Most CAD systems are using technology that was developed back in the 90s, which is called history-based modeling, or what we call ordered in Solid Edge. And basically this is just one feature on top of another feature on top of another feature to come up with a solid model. If you want to make an edit to that model, you have to roll the model back, find the feature to change, make the modification, and have the model recalculate, which is really prone to failure because you end up with dependencies that you didn't necessarily intend to have. Just to show you what that looks like, I'm going to come in here to this pulley. This was modeled in ordered, again, the history-based technology from the 90s. This is an old model. In Solid Edge also you can use history-based modeling if you want, but I'm going to show you what the problem is with it. So here you can see that we have a pulley. We want to make the pulley 20 millimeters wider to accept a wider belt. Notice that it has a cutout down here for a bearing, that it looks the same on both sides. And so we want to make a change, make it 20 millimeters wider. So the first kind of issue that you have is you have to figure out which one of these features you actually have to edit to make the modification. And in our case, you can see protrusion 1 is what highlights there. So let's go ahead and go into protrusion 1 and edit that. And what you're going to see is it rolls the model back, all the way back to the very first feature, which was just a circle extruded to a depth. I'm going to change that then to 55 to get that 20 millimeters wider. And that's great, but the problem is when you click finish, because it has to recalculate all of those features, and now you can see that the hub in the center has completely disappeared, and that's because of some dependency on how the part was modeled. They did not take into consideration that this model could actually get wider and build that in so that it did not fail. So you spend a lot of time trying to fix models when you make modifications in a history-based CAD system. Now I'm going to undo that because I'm going to show you how you do this in synchronous technology in the new paradigm. Before I do that though, I want to just give you a brief introduction to what we mean by synchronous technology and removing that history. So let's go into a new file. I'm just going to start a blank part file here. And here we have our reference planes here in the center, or our base coordinate system. And I'm just going to draw a rectangle by center. Start drawing out here. Let's make it 300 by 100. Now, what you see here is that we have what we call a region, this enclosed area within the profile. If I click on that region, I can start to extrude without actually having to go into a command. Automatically puts me in extrude. If I hit the shift, I can go in equal directions. I'm going to hit shift again, go in single direction. Okay. The other thing I could do is I could drag that origin to an edge. What that does is allow me actually to go into a revolved extrusion, again, without having to actually pick a command. Our case, we do want to just do an extrude. And the thing I want you to pay attention to is the dimensions that are on the sketch. When I click to accept that, you can see that those dimensions migrated from the sketch directly onto the 3D model. Because in synchronous technology, we actually are going to edit the 3D model directly. We're never going to go back to that sketch to make the change. So in other words, if I click on that dimension, I want to make it 500, you can see I modify that dimension directly on the model itself. So there I've made some modifications. The other way you can make modifications is by clicking and dragging on a face. So if I click on a face, the thing I want you to pay attention to is up in the right corner, this design intent panel. This is monitoring our model, looking for specific geometric conditions, and it will maintain those geometric conditions for me automatically. Notice as I start to drag, you're going to see that list drop to only symmetry. That's the only thing it found within the model that it needs to maintain for me. If I decide I don't want that, I can just click S or uncheck it in the design intent panel, and now it's only going to move the face that I selected. In my case, I want to keep it symmetric, so I'm going to click S again, and it's going to maintain that symmetry. And I could key in a value here. I only want to move 50 millimeters. Now, just to prove to you that we don't actually go back to the sketch, if I look at the sketch, you can see it's still the original size of the box. As a matter of fact, I can even delete that sketch because we don't need it. It's not part of the solid. So you can't do that in other CAD systems because it would have just destroyed the model because they rely on that sketch. Let's go ahead and continue modeling. I'm going to draw a line actually vertically across this face. Notice what that did. It broke this into more regions. I click on a region, start to drag. If I pull it down, it creates a cut. If I pull it up, it creates an extrude. Now, if you think about how I modeled this from the side view here. So from the front view, XZ plane there, drew a profile and extruded it along Y. The next extrusion was straight up along the Z axis. But then what if later I decide that this vertical section needs to be rotated 15 degrees? Well, because the way in which I modeled it, if this was an ordered model, I can't extrude at 15 degrees. I would have to actually cut it off, draw it from the side profile at 15 degrees, and then extrude along the y-axis. So again, you have to think about how you're going to build the model, how you're going to edit the model when you're building it. With synchronous technology, we don't care how you built the model. You simply select what you want to change, take your steering wheel, which is our editing tool, put it on the corner you wish to rotate about, click on the torus on the steering wheel, and start rotating it very quickly and easily. With that same steering wheel tool, I could pick the vertical arrow and drag it up. I could move the steering wheel down here on an edge to align with that edge, so I can move it along this axis. You simply select what you want to change and make the edits without any consideration on how the model was built. Alright, so now that we have an understanding of what Synchronous does, let's go back to our pulley. Let's edit the pulley and let's move it to the new technology. Simply right click on the last feature, move to Synchronous. It pushes it all up under Synchronous, which is again the new technology. And how would I make that same edit in Synchronous? Well, just like I did on the block, you select what you want to change. I'm going to click on this face. I'm going to get this face. I want the hub. And I also want the depth of the bearing cut out here to remain. And I also want this inside face. All right. So now that I have that selected, I'm going to rely on the Design Intent panel to maintain symmetry within the part. And I only have to go 10 millimeters to make it 20 millimeters wider because again it's moving symmetrically. So let's go back to our assembly, and one thing I'll do is hide all the PMI dimensions here. Notice of course there are several other parts that need to be edited also to make room for that 20 millimeter wider pulley. Now in other CAD systems you're going to have to go into each one of these parts individually and modify them to accept that wider pulley. With Synchronous we can do it from the assembly level. Notice the yellow diamond or the yellow box next to my cursor. If I press Control Spacebar, that changes to a blue diamond. What the blue diamond does is allow me to actually click on synchronous faces of parts within the assembly. So when I click on these faces, I don't need to pick an inside face because it is sheet metal. The bearing has already moved because of an assembly relationship to that cutout in the pulley. So I just need to move the end face of the spacer, and I'm only going to select one edge face of the cutout area because again I'm going to rely on that Design Intent panel to find the upper face which is coplanar. Once those are selected, you can see there's 4 different parts. I'm modifying all 4 parts at the assembly level exactly like I did with the pulley, and I'm just going to go 10 millimeters again because it is going to stay symmetric. If the pulley had been synchronous to start with, I could have changed the pulley along with all of those parts at the same time. Notice the sheet metal parts are different widths. I may want them to be the same width. I don't want to do a lot of measuring. So from the assembly, I can create a face relationship of coplanar. What does that mean? Well, if you take the cursor and just sit there, you can see that we have some tooltips that are actually videos to show you exactly what that command does. So let's go ahead and use that command. We select the face that we want to move. which is this one. I accept it and I want it to move to this face, and because it is sheet metal, it moves the whole entire thickness chain. Okay, no measuring required. We also have some other tools. If I press Shift and Spacebar, we get a selection manager, which allows me to find all the coplanar faces between any of the parts in the assembly. Add them to the select set, run the same command again, and I want to make all of those coplanar to this cutout. And again, modifying multiple parts at the same time, establishing those relationships there. So very, very cool, very, very powerful to be able to do that at the assembly level, not having to go into each part individually, have a whole list of dimensions that I need to change in each part. We can do it all right here at the assembly level. Now what about imported parts? Things like GrabCAD, parts that you may use from GrabCAD. So let's go open up a STEP file, open that into Solid Edge. And the problem with imported parts is they are featureless. Some people call them dumb solids. So with synchronous technology, there's no such thing as a dumb solid. Because we don't care how the part was modeled, we can add intelligence whenever we want to. So for instance, I could add a dimension to this pad and I can just change it directly because we don't care how the model was built. We're going to edit the solid directly. Notice the blue face there. If I start making a change, that's the face that's going to move. If I want it to be the other side, I flip the arrow, or I can go equally in both directions and make it wider. What about these gear teeth? What if you want to change the number of gear teeth? Well, there is no pattern there to change. But with Solid Edge, we have some technology for recognizing patterns. So I simply select the faces that I want it to go investigate to see if it finds a pattern of those faces. And in fact, it instantly found a circular pattern. Not only is it a circular pattern, but 3 of the instances have been suppressed. It's just how powerful that command is. Once it becomes a real pattern in Solid Edge, then I can come in here and make a modification to make it have 12 teeth instead of 10 teeth. So that was a circular pattern. It will find also linear patterns or rectangular patterns. So let's come in here and just select one of those teeth. Notice that again, we get a real pattern now in Solid Edge, becomes a pattern that we can actually edit. So I could make it go the length of this pad, and I could also change the count to a different number of teeth. So very, very powerful functionality. Now notice that it has this little raised area here. If I click on this and drag it, notice that it's only changing one side and it's not finding that it's symmetric. And that's because the entire model is not symmetric about the base coordinate system. The beauty of synchronous is because we're not relying on a sketch and its location in space, you can actually select the entire solid. So let's take the design body. I'm going to strategically find the midpoint of the tooth here, and I can drag the entire solid and center it on that base coordinate system. What that does for me then, if I click on that face and start to drag it again, symmetry kicks in the design intent and maintains that symmetry for me automatically. So hopefully that gives you a brief introduction of what synchronous technology means and how powerful it is when it comes to modeling and editing parts that you're designing or assemblies that you're designing.